In this video, I'm going to dig a little bit more deeply into the valve body, and specifically what the solenoids are doing, what the valves are doing, where the oil flows, etc. So if you have problems with your transmission, this might help with diagnosing where those problems might be coming from. The way I did this was I took multiple photographs of the different layers of the valve body and overlaid them in Photoshop, and then was able to sort of follow the bouncing ball of where the fluid flows, because the way these work, there are multiple layers, and there's like a couple of train networks, one on top of the other. So if you wanted to go from one place to another, you could go across here, go up, go down, etc. It's pretty convoluted where everything goes, and without a tool like that, it's pretty hard to work out exactly what's going on. For those who might be interested in having a look at the Photoshop file that I made, I'll put a link in the description for where you can download that. It has all those photos all overlaid with each other, as well as labels of where oil goes to and from and that sort of thing. So if you're interested, have a look at that. This side of the valve body is the bit that is going to be bolted to the transmission casing. So this is where all the oil comes out of. There are basically 11 different outlets for where oil can come out of. There are lots of bolt holes, etc., but you can see where I've labelled these when I was playing with where the outputs went to the different parts of the transmission. But there are 8 for the shift rods, because there are 4 shift rods. There needs to be an extension and a retraction of each one of those. There's one for each of the clutches. There is one for the lubrication gallery, and there's one to and from for the cooling. When we pull this apart, there are 3 basic structures. You've got the underside here. This would be filled with, like, there are these dampers. So each of the solenoids, the EDS solenoids, which I'll talk about in a moment, has a damper, which is like an accumulator that sticks in here that dampens out the pressure as these get activated. It also has a couple of one-way valves here and a few up the front here. These are for the cooling up the back here. And there are a couple up the front here, which is for the clutches. They're not really important to describe exactly what's going on. If you want to look at where they are, have a look at the other video on the valve body that I made. In between the channel plate and the valve body part here is a separator plate here, which is the thing that allows flow to go from one side to the other. And it has this bonded gasket, which seals nicely one side against the other. It also has lots of little tiny holes that are metered specifically for the route that it's taking to meter that fluid through it at a certain rate. So I'm not sure if you can notice it, but there's lots of those all over it. In valve bodies of old, they would have these little plastic discs with these little tiny metered orifices in it, whereas now they're able to make these so they're all in the separator plate. And then here we have the valve body itself. So this is where most of the work is done. So I've got the solenoids down here and lots of valves in here that control where the fluid eventually comes out of the bottom of this. Without any other numbering system, the valves I've numbered, there are 14 in total, or 11 along here. So starting from the left, 1 to 11. And then 12, 13, 14 up the top. I'll talk about what those valves do in a moment. The solenoids themselves, the numbering for those, which is normally used, and it's a bit convoluted, but these solenoids here are EDS solenoids. So ED stands for duty cycle. So these are the ones that can control the output from them. These ones are MV solenoids, so they are just an on or an off. These, I think, are a 7-volt solenoid. These are 12 volts. So the numbering of these: EDS1, EDS2, EDS3, EDS4, EDS5, EDS6, and MV1 and 2. What do they do? And we'll dig into this more deeply in a moment. These 4 solenoids here, so MV1 and MV2, EDS5 and 6, control the 5 valves over here, and that controls the shift rod actuation. EDS1 controls clutch 1, which is the larger of the 2 clutches. EDS2 controls clutch 2, and EDS3 and 4 do a funny bunch of things over this side of the transmission, as well as control the cooling and pressure. EDS 3, which is that one there, is primarily controlling the pressure, which is going to happen with these valves down the back here. And EDS 4 controls our lubrication and cooling valve, which is the one down here. So the basics of the valve body operation are, so the fluid is going to be sucked out of the pan by the filter, which comes out of this round hole here, comes up to the pump. It supplies pressure, it comes back down through that big square hole, and it's going to come back down into the valve body, and then it's going to be distributed as required to all those items. The problem with the solenoids is that the pressure that's normally supplied from the pump and that is going to be used to clamp the clutches is very high, normally in the order of 200 to 300 psi, which is far too high for these solenoids to deal with. If they were to deal with that, then they would need to be much larger and much stronger, etc. So what they do is they reduce the pressure to the solenoids, and then that pressure is a signal pressure that is sent to a valve, which then moves that valve, which will allow that full pump pressure to be applied to an actuator or a clutch or something like that. That reduced pressure comes from this valve in here, the one in the middle, valve 6, which is the pressure reducing valve. And I'm not sure if you can see it here, but that comes from that spot there. And the way all these valves work, except for one here, which I'll explain later on, but they sit in a position that is got a spring on the end of it, so it's pushing it in one position, and then when pressure is applied, it moves it against that spring to the position that it needs to. But pump pressure would come into here, and then because of the spring pressure, it allows that to move, and then a reduced pressure comes out of here, and that gets applied all the way along here to the fronts of these solenoids. And the solenoids themselves, and this is one of the EDS solenoids, all that pressure reducing pressure goes into the snout here, and on a solenoid like this, it can come out of there or it can come out of there. And depending on the type of solenoid that it is, it will, without any power applied, come out of here, or it will come out of here. And the orange ones and the white ones work in reverse of each other. The black ones, the MV solenoids, which are just the on or off, instead of having the ability to vent out the back, they, when they are activated, will allow flow, that pressure reducing flow, to come in there and come out of there. If there's no power applied, it's just completely blocked, so nothing comes out. And so for each of the solenoids along here, it gets the pressure at the snout, and if it's allowed to come out of that position there or that position there, it's going to come out of one of these spots here. And what that does is it allows pressure then to come to another part of the valve body to then give that signal to that valve that it's applying pressure to. If it's, for example, venting out the back of this one here, then what it does is it vents it, and here's a perfect example, it just vents it out of the valve body. So instead of coming out of that one there, it's going to come out of there when it comes out of the vent at the back. And if it's vented out the back, it's not doing work. It's just allowed that pressure that's coming through here is just going out the back, and it's just going back into the pan and not doing any work at all. For these orange solenoids, the way they work is that with no power applied, all of the fluid is going to be vented out the back, and it's only when power is applied that it then allows fluid to come out of here. At a full 12 volt signal, it's going to completely block off the back, but these being a duty cycle, they'll get a pulse width modulated signal from the transmission control module, which will control how much this is open, which will regulate how much comes out of here and how much comes out of here. For the black ones, like I described before, these are either on or off, so if they get 12 volts, then it comes out of here. If not, it's completely blocked. For the white ones, these, when zero power is applied, will have all of the fluid coming out of here, none coming out the back, and the more power is applied, the more is going to be coming out of the back here. Why they are different, hopefully that will become apparent in a moment, but basically these two are to do with pressure control and lubrication control, and you want it to be doing work if you have a complete electrical failure, whereas with these orange solenoids, if I have a complete electrical failure or something goes wrong, I do not want a signal to make it do something like apply a clutch or to try and make a shift rod work. Finally, there's this big one here. which is for clutch 1, and it operates in exactly the same way as these other orange solenoids, except for the fact that instead of venting out the side here, because there's nothing here, it vents out the back there. This connection point here, all it does is just turn the fluid flow through 90 degrees so this solenoid here can operate. Why is it different? Well, the only thing that I can come up with is they needed to find a control for clutch 1 for smooth take-ups, maybe for launch control or something like that. But it looks like it, from what I can see, that they probably initially had one of these in there and they went, oh, it's not actually working okay. We need something that's a bit more elaborate inside here that's going to give us better control. So they used this thing, and they needed a bigger solenoid, but because of the limited space here, they had to turn it through 90 degrees. One of these will actually fit in here, and you can see there's even a little vent there for if one of those went in there to vent out of there. So if you jerry-rigged the harness for one of these to fit in there, I reckon it'd probably work okay. Probably not as well as with this one here, but that's what it looks like to me. For shift rod actuation, the way this works, and I'm not going to pull the valves out just so they don't get damaged. If you want to see what the valves look like, I've got all those photographs with the one of all the valve body layers. So they're all there if you want to see where the valve would be in its actuated or relaxed state. But hopefully what I'm talking about here will make sense without me actually having those valves out. Valves 1, 2 and 3 determine which shift fork is going to be selected. So MV1, which is this one here, operates valve 2. MV2 operates valves 1 and 3. And the way these work is that if pressure is going to come out of there, it's going to come out the other side here and be applied to this position here, which then moves it. If there's no pressure, the spring up here will push it back in the other state. So we can operate in either a down or an up state. Same with MV2, it applies pressure to that position there, or that position there, which will move each of those valves. And what that does, because these have a bunch of different sort of notches on them that allow flow to different places. And what happens with the pressure from EDS 5 and 6, when pressure from, just say for example, EDS 5 was starting to be actuated, pressure comes out of here, it's going to come into there, which pushes this valve up. This spot here is where I've got full pump regulated pressure, and if this is allowing this valve to move, it's going to allow that pressure to come out of here. And what that's going to do is come to these spots from either EDS 5 or EDS 6, which is this output regulated pressure for them. It's going to come to a spot on valve 2, which is controlled by MV1, and it's going to be either there or it's going to be there. And I'm not sure if you can see this, but the pressure that's being applied to there, depending on the valve position of valve 2, it can either go down in this direction down here, or it can go in that direction over there. The pressure from the other EDS valve, which is going to go to that one there, can go either to that one there, depending on the position of it, or there. And then, because now you can see, for example, that pressure would have either gone to there or there, depending on the position of this one here, it's going to either come out there or there, or there or there. And the same thing for the pressure that comes out over here, it's going to go to there, or it's going to go to there or there. And what does that do? Each one of those, when you look at all the combinations, is 8 separate combinations, which are the 8 movements of the shift forks, because I've got shift rods 1 through 4, and each of those has an extension and retraction. And the way this works is that for each combination of MV1 either on or off, and MV2 either on or off, we'll select one of the shift forks. And then depending on which one of either EDS 5 or 6 applies pressure, we'll supply it to one or another different spots, which is either an extension or retraction of that shift fork. I'll put up a matrix in a moment, because when I went through it and worked out where it all went, it's pretty obvious how it all goes. It didn't seem as though EDS 5, for example, was all retraction and EDS 6 was all extension. It was more just that MV1 and 2 controlled which shift fork, and then it would supply either EDS 5 or 6 pressure to either extend or retract that. For clutch pressure application, They're through these valves here, so valves 7 and 8. Valve 7 via EDS1 controls clutch 1, EDS2 via valve 8 controls clutch 2. And when these are allowed to be activated, because they would normally be venting out of the valve body, when pressure is allowed to come from here, it's going to come up to a position here. And if you want to have a look at what these valves look like, because these are a bit funny in that there's two parts to them. There's a pressure control valve part up here, and there's also a funny little sort of stopper valve that can move down the bottom here. So when pressure is applied here, it's applied to the bottom of that pressure control valve on this side of that stopper, which is going to be in here, which then allows pressure, because in here is where we've got full pump pressure. So when the signal is given to this position here, it moves the valve up against spring pressure. That full pump pressure is allowed to then start to be metered into this spot here, which if you then follow that outside of the valve body, that goes to clutch 1, and in exactly the same way for EDS2 and clutch 2, when it comes out of there, it'll go into there, which allows that full pump pressure to be metered into the position here, which then goes outside the valve body to clutch 2. Now that all seems pretty simple, but it starts to get a little bit more complicated than that, because these valves over here also have an input into pressure that gets applied to the bottom of that stopper, which pushes up this way, which from what I can see, and it's a bit hard to exactly know what's going on, but it seems as though that when pressure is applied to one of these and it starts to move, once a certain amount of pressure is applied, it then applies pressure via these three valves over here to the bottom here to then push it up and lock that into place, so full pump pressure is always going through to that clutch. And the way that seems to work is that firstly, there's this funny valve here, which unlike the others isn't spring loaded. It's got this funny ball valve here, so it can either live in one spot or the other, and depending on which spot it lives in, it then allows pressure to be applied to either this spot here or this spot here, to that floating piston or that little stopper that's allowed to move up and then push it into the full pressure position. The pressure that is given to that comes via this valve here. So valve 11 here is controlled by EDS3 and 4. It gets pressures both from EDS3 and 4 into there, which allows this piston to move down under spring pressure, which then allows our pressure reducing valve pressure to come through into here, which then gets pressure controlled again by this valve, which then gets fed into this valve here. And depending on where it gets fed into this valve, or the position of this valve, because it's going to go into that position there, and that will either go up into there, which is for one of the clutches, or if you look at the way this goes through the valve body, it'll go down the other side here into, I think it's that position there, so it could go into the other clutch. But enough said that depending on the pressure that is applied to one of these clutch activation areas here, it will then move this position into one or the other, which then allows flow of oil to come via these positions to either that position there or that position there to lock that clutch activation piston into that full pressure position. Well, that's what it seems like to me. EDS3 and 4, whilst it looks like it might control something in here, it doesn't. When you look at the flow through the valve body, it comes all the way up the top here and has inputs into these two here, which are the pressure control valves. I'm not going to pretend that I think I know exactly what's going on here, because there are so many feedback loops which it seems to use to really control the pressure quite accurately. But enough said that EDS3 has inputs up the back here to both of these to control those. EDS4, its input goes back up here, and this valve here, when you look at where the valve body flow goes, is for lubrication mainly, and the lubrication seems to have two outputs, either a high or a low pressure system, depending on what is happening with EDS4, or a graduated in between. So it seems like there is either an absolute minimum or an absolute maximum lubrication level, or something in between. This also controls where the cooling flow. So how might this information help you? Well, if you can narrow down specific areas where you're having problems, you might be able to work out where the problems are occurring inside the valve body rather than just replace the whole thing. If it's a problem overall, it might be a pressure control problem, and in transmissions in the past that I've seen, that is oftentimes where issues can occur, because anything that's controlling pressure, and especially large pressure control valves, they are constantly moving back and forth, and that's the sort of thing that creates wear, whereas some things which just move to one position and stay there are generally not the things that wear. For the solenoids, you can remove these and test them as per my other video, or you can test the resistances, which will just tell you if it's completely shot or not. Easiest way to do that is just at the TCM when you look at the pinout for that. Or if you're looking at the valves, generally because the valves themselves are made of anodized aluminium, they are harder than the bores, so the valves generally aren't the things that wear. It is the bores, and so if you remove the valves out and inspect the insides of the valve bores, oftentimes you'll see ridging in them. So these distinct lines, they're a bit difficult to see, but if you look closely, you can see them. If the bore is starting to wear, especially on those pressure control valves, if they are just perfectly smooth, then they're generally going to be pretty good. Valve body specialists and transmission specialists can vacuum test different areas just to check if the valves are sealing correctly. But this might help you out in being able to diagnose where maybe your problems lie.